Here we're going to combine the future value of an annuity with compound interest. So suppose you invest $200 per month for 6 years into an account earning 2% compounded monthly. After 6 years, you leave the money without making additional deposits in the account for another 30 years. How much will you have at the end? So you've got 0 years, then 6 years, then 30 years after that. So you have a future value of an annuity for the first 6 years, or an annuity rather. And then for the 30 years thereafter, you've got compound interest. So the first thing you're going to do is you're going to compute the future value of an annuity after 6 years. And then you're going to use that future value for compound interest. All right, so first let's do the future value of an annuity. You got $200 per month, that's your deposit. Then 6 years is T, you've got 2% interest R, and your compounded monthly, so that gives you N. We know we're doing a future value of an annuity, so here's our formula. And then here's what we've captured from the problem so far. We're not worried about the after 6 years part yet because we're just doing the first 6 years. So let's go ahead and plug all these values in. And as we've done in the past, let's work with these fractions and put them in decimal form. Next, we're going to work inside the parentheses. Oh, and we're going to do the exponent. Hey. So now we're going to apply the exponent to 1.0016667. And so we're just working on getting that numerator simplified. Let's go ahead and subtract off that 1. And so now we have just two numbers, one in the numerator, one in the denominator. And we'll go ahead, put those in our calculator and divide. So we've got 200 times 76.43, etc. And we'll go ahead and multiply that out. But let's not round yet because we're going to use this value for what happens in the next 30 years. So we're going to take that 15,286.10485. That's our principal. That's what we're going to let sit as a lump sum for our compound interest. And we're going to do this for 30 years. So instead of time being 6 as it was before, time is 30. But it's still monthly. I've still got that 2%. And I still want to know how much will I have at the end, my future value A. So here's compound interest formula. And let's plug in what we've got. We don't know A, but our principal is 15,286.10485. And then I've got my 2% or 0.02 over 12. And then my exponent 12 times 30 because I've got 30 years. So let's go ahead and work that fraction and the exponent. Let's finish off what's in the parentheses. Let's apply our exponent. Oh, we're running out of room. All right, let's multiply these two numbers through and round to the nearest cent. And this is what we would have at the end. So again, for the first 6 years, we're contributing, we're making deposits of $200 per month. Then at the end of 6 years, we're like, you know what? I don't want to do that anymore. I'm just going to let it sit. Maybe you changed employers and you don't feel like rolling over your 401k, whatever's going on, you just let it sit. And then 30 years, you're like, oh, I forgot about that account. I wonder how it's doing. Well, it's doing pretty good. You got $27,839 with 19 cents.